We're going to first start by labeling the initial side and the terminal side of an angle. So an initial side is where it begins, and a terminal side is where it ends. Now, typically, if you are looking at a coordinate plane, the initial side will be on the positive x-axis, and it can either open upwards or downwards. So now if I were to label this next one, if my initial side were here and it goes all the way around 360 degrees plus a little bit more. So here's my terminal ray. Now if I were to take an initial side on the positive x-axis and I open downward, now I create a negative angle, and here is my terminal ray. So if I were to have a point on the unit circle that I label x comma y, the hypotenuse of this triangle is equal to 1, and I drop a segment down to the x-axis to make a right triangle. This leg is x and this leg is y, and this angle is theta. All right, so I have labeled 4 points on the unit circle at 0, 90, 180, and 270 degrees. All right, so if you remember from geometry, so is sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So now we're going to use this triangle in red, and we're going to label sine using the specific sides x, y, and 1. So if I were to look at this angle and I look at the sine of that angle, it would be opposite over hypotenuse, which is just y. If I were to look at the cosine, it's adjacent over hypotenuse, which is just x. If I were to look at tangent of that angle, that's opposite over adjacent, which is y over x. So these 3 additional trig functions are considered our reciprocal functions. So sine has a reciprocal called cosecant, and that is hypotenuse over the opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over the opposite. All right, so as you can see, if we were to use the red triangle, the cosecant would be 1 over y, the secant would be 1 over x, and the cotangent would be x over y. And this would apply to any point on any given unit circle, not just a point in the first quadrant. For this angle, which has a terminal ray in the second quadrant, I'm going to create a reference triangle by drawing in a vertical line that goes perpendicular to the x-axis. This is going to be my reference angle, which I'll label as theta prime. So what you would do is you would basically figure out how much is the difference between 180 and the original angle. Now, if it's on the left side and it ends up in quadrant 2 or quadrant 3, you would subtract from 180, 540, 900, etc. If you have an angle that terminates in the first or fourth quadrants, however, you're going to subtract from 0, 360, 720, and so on. In terms of radians, let's say that this were my angle ending up in the fourth quadrant. My original angle is here. The reference angle is the difference between 2 pi and the original angle measure. So if I'm on the right side, I would subtract from either 2 pi, 4 pi, 6 pi, and so on. If I were on the left side in quadrant 2 or 3, then I would subtract from pi, 3 pi, 5 pi, 7 pi, and so on. So in this next section, they want us to sketch the angle in standard position, which means that the initial side of the angle is on the positive x-axis. And then after we draw the angle, we want to figure out what its reference angle is. So 210 degrees, I know, is more than 90, it's more than 180, but it's less than 270. So I know it's closer to 180 than it is to 270. And so after I draw this 210 degree angle, I need to figure out what is the reference angle. So the reference angle is, if I were to make a triangle, a right triangle from the terminal side to the x-axis, how many degrees is this angle. So I've gone a little bit past 180, so I have gone 30 degrees past 180, and that is my reference angle. One way to check if you have the correct reference angle is to make sure that the reference angle is acute and positive. This next one, they want us to create a negative 210 degree angle, so we are going to go negative 90, negative 180, but not as far as negative 270 degrees. So we are going to go a little bit past 180. And we need to figure out, well, what is the reference angle, which is the angle inside the right triangle that's created by drawing a perpendicular to the x-axis. So think about these numbers as just being positive. We rotated 210 degrees in a negative direction, but we can leave off the negative sign. And we went past 180, so it is 30 degrees. It has to be acute and it has to be positive. All right, so for the last one on this page, we have negative 570. So I know that that is going to start at the positive x-axis and rotate at least 360 degrees. And then another 90 degrees would be negative 450. Then another negative 90 would be negative 540. And another negative 90 would be negative 630. So I am going to go a little bit more than negative 540. So I'm going to drop my perpendicular to the x-axis and figure out how many degrees this angle is. So I have gone negative 570. It means I want to subtract 570 minus 540, and that leaves me with 30 degrees again. So as you can see, all three of these angles have 30-degree reference angles. Now, since numbers 2 and number 3 end up in the same quadrant and in the same location and the same reference angle, these are considered to be coterminal angles. And these are angles that share the same terminal side. For numbers 4, 5, and 6, we're going to look at the reference angle for an angle measured in radians. So as you'll recall, every 90 degrees is pi over 2. So this would be pi over 2, pi, 3 pi over 2, and back to 2 pi if you go in a positive direction. So pi over 3 would be in the first quadrant, and that is equivalent to 60 degrees. So here is this angle. I'm going to create my right triangle by drawing a line straight down to the x-axis. And since I am going to rotate back to the x-axis the same amount that I had rotated to the terminal ray, then my reference angle is pi over 3. For number 5, if we were to rotate in a negative direction, pi over 4 is 45 degrees. So this would be going negative 45 degrees. And so if I were to draw my triangle back to the x-axis, my reference angle is pi over 4. Recall that reference angles, again, have to be acute and positive, just like when they were with degree measures. For number 6, we're going negative 7 pi over 6. So we're going to go in the negative direction. This would be negative pi or negative 180 degrees. So we're going a little bit more than that. So how much more are we going past the x-axis? Well, we had 7 pi over 6 was our original rotation, and if we were to subtract off 1 pi, that's 7 pi over 6 minus 6 pi over 6, which is pi over 6. So that is your reference angle. For problems 7 and 8, we're going to sketch this point in the coordinate plane, and it says that it is in quadrant 3. So if it's on the unit circle and in quadrant 3, then we know it's a distance of 1 unit to the origin. We've been told that the x-coordinate is negative 3/5, which means that we need to figure out what the y-coordinate is. So as a reminder, since you have a right triangle, you can create a Pythagorean Theorem equation. And we're going to do negative 3/5 squared plus b squared equals 1 squared. Recall that when you square negative, that becomes positive. So this is 9/25 plus b squared. And 1 squared is 1, but I'm going to write it as 25/25 so that I have common denominators. When I subtract 9/25 from both sides, I get 16/25. And when I take the square root of both sides, I would get plus or minus 4/5. Now, since I'm in the third quadrant and I have to go in a negative direction, then this would be -4/5. Now, to find our 6 trig ratios, we're going to recall this chart from the front side where we know that sine is equal to y/1, cosine is x/1, and tangent is y/x. All right, so sine should be your y coordinate, which is -4/5. Cosine is equal to -3/5. And tangent is equal to y/x, which is -4/5 over -3/5. Since we have this complex fraction, we can cancel out our denominators, and we get 4/3. So if it helps to label this point is at -3/5, -4/5. So you don't mix up which one is x and which one is y. All right, for the other 3 reciprocal functions, these are easier because all we need to do is flip them over. And there you have your 3 reciprocal trig ratios. All right, for our last problem, we're going to have a y coordinate of 2/9. It tells us that the angle is between 0 and pi/2, which is measured in radians. So now we know that this has to be in quadrant 1. And so there is some point, we don't know exactly where it is, but we know that it is on the unit circle. It has a hypotenuse equal to 1. It has a y coordinate of +2/9, and we don't know an x coordinate. But we do know it's in the first quadrant, so we can label it as such. All right, now you're going to do Pythagorean Theorem. So we're going to do a squared plus b squared equals c squared again. And so we have x squared plus 2/9 squared equals 1 squared. So we have x squared plus 4/81. And to make it easier, I'm going to make 1 equal to 81/81, so that when I subtract 4/81 on both sides, I get 77/81. And then I need to take the square root of both sides. And so I get square root of 77/9. But I could either have a positive or a negative. And since I'm in the first quadrant and I'm moving to the right, that would be a positive direction. So this would be positive root 77/9. All right, so when doing my 3 trig ratios, I know that cosine is my x coordinate. I know that sine is my y coordinate. And I know that tangent is y/x. All right, so when you simplify tangent, we have a complex fraction with the same denominator. So if we were to multiply by 9/9, those 9's cancel out. And we are left with 2/√77. So as a reminder, you can't leave a radical in the denominator. So if you do have one, you multiply by that radical, and you end up with 2√77/77. For my 3 reciprocal functions, I'm just going to take the reciprocal of the corresponding trig function. Now, I do need to rationalize in some cases. So for example, secant will be 9√77/77. For cotangent, I'm going to take the reciprocal of the 2/√77, so I get √77/2. One thing that you could do to check your answers is verify which quadrant your angle is in, and remember a phrase, it's all-star trig class. So all things are positive in the first quadrant. Just sine is positive in the second quadrant. Tangent is positive in the third quadrant, and cosine is positive in the fourth quadrant. All other items would be considered to be negative. So all things are positive in the first quadrant. Sine is positive in the second quadrant, because if you notice, the y coordinate is positive. Tangent is positive in the third quadrant because the x and y coordinates are both negative. So when you do y/x, you get a positive. And then cosine is positive in the fourth quadrant because your x coordinate is positive, but then all other items are negative. And that's just referring to sine, cosine, tangent, and then the reciprocals will just follow suit with the original trig ratio. All right, so the phrase to remember for that is all-star trig class.